observing and predicting motion of a falling object. Our objective is to record position data of the falling stack of paper
Okay.
and create a model using the data. Just like in our first lab, we used Tracker to extract the actual position data over a period of time. We will use this position data to plug into our Python code to then get our predicted position data, just like we did in the first lab. We put the same things in this code like we did in the first code, so it would repeat the Newton's second law and velocity formula pattern many times to get a lot of different position points for us at certain time intervals. Before we get to the predicted position data, we should probably assess the actual position data that we extracted from Tracker. This is a graph of our tracked position data. And as you can see, our stack of paper does not just fall in a straight line from the center of the y and x-axes. It falls and moves side to side a little. This could be due to the fact that I put a little too much pressure on the stack of paper when I released it, or air resistance is carrying the paper and making it move, not causing it to fall straight down. As you can see, our predicted position data of the paper stack is completely linear. It is not moving differently as our actual position data. The reason for this is because it says that drag is negligible, which means it just falls in a straight line, unlike our other graph. This is easier to see with the graphed different sets of data. If I had initially pushed the stack of papers down, there would be much more force acting upon them initially rather than just the gravitational force, so the velocity would be much greater. So the change in position over time would be much greater. The position would change much faster due to the greater velocity and greater force initially.